Hello, my name is Davis Binger, and let's talk about derivatives of parametric equations. Today we will be looking at problem 4 of the 11.1 handout. We will consider the parametric curve given by x equals t squared and y equals t cubed minus 12t for values of t between negative infinity and infinity. We will then find dy dx in terms of t and all points x, y on the curve for which there is a horizontal tangent line. Let us recall the basic method to find the derivative of a parametric curve. We can express dy dx in terms of dy dt and dx dt in the following way. The derivative is equal to the ratio of the derivatives with respect to t, that is dy dt divided by dx dt. In our case, each function is a polynomial function of t, and it is a simple matter to calculate the derivative of each with respect to t. The derivative of y with respect to t is 3t squared minus 12, and the derivative of x with respect to t is just 2t. Hence we have found the derivative in terms of t. Now on to the second part of the problem. We want to find out which points correspond to horizontal tangent lines. The question is, how does a horizontal tangent line relate to the derivative? Recall that the derivative is equal to the slope of the tangent line, and if we have a horizontal tangent line, the derivative is 0. Thus we will set our derivative equal to 0 and solve for t. So we have 3t squared minus 12 divided by 2t equals 0. We'll multiply through by 2t. Now let's just keep this in mind. We want to be careful if at the end we have a solution of t equals 0. We may need to go back and check and see if this is a real solution to the equation. We have 3t squared minus 12 is equal to 0. Adding 12 to both sides and dividing by 3, we get t squared is equal to 4, or t is equal to plus or minus 2. Thus we have 2 points, one corresponding to positive 2 and one corresponding to negative 2, at which we have a horizontal tangent line. Now we can plug in t to find the x and y values. The t value of plus or minus 2 is great, but we are asked for the specific points in terms of x and y coordinates. So at t equals 2, we can find the value of x is 4, and the value of y is negative 16. At t equals negative 2, x is equal to 4, and y is equal to 16. Thus we have found the 2 points at which we have horizontal tangent lines. There are 4, 16 and 4, negative 16. Thank you for watching, and as always, you can reach me by leaving a comment below or emailing me at binger@math.ohio-state.edu. Thank you, and have a good evening.